Hello, my name is William Danchin. I'm the president of PwC Pure Water Corporation, located in Vancouver, British Columbia, Canada. We're located here at the moment at our subcontractor who manufactures our water treatment plants out of polyethylene, polypropylene, and PVC materials, bar plastics. They supply a wide variety of water treatment tanks and do a variety of fabrication here at the location in Abbotsford, BC. I'd like to take this time to explain to you a little bit about how our DEFERUM works and this particular model. Our DEFERUM plants are primarily designed to remove high levels of iron. Iron levels up to 75 parts per million. This technology can be applied to groundwater, surface water, and seawater treatment applications, and can also be combined with membrane technology, flocculation, ozone, and other types of treatment technologies to be able to remove a very wide range of contaminants. This particular model consists of about 6 major components. The tank body, which you see here, this vertical assembly is called the hydro robot. The device that you see at the top of the hydro robot, you may not see it in the picture, but it's black. It's called the AKB aerator degasifier, and I'll explain to you a little more about how that works. And inside the tank, there's some assembly configuration. Halfway down this tank is a retaining ring, stainless steel ring, and at the bottom a distributor. Now, this particular filter plant works without the need of power, and this is one of our major benefits. There are no moving parts, there's no valves, there's no electronic controls. The system is self-adjusting, and the backwash is self-regulating, which means it'll backwash when it needs to, and it backwashes by gravity. To explain how this plant works, basically we have a valve bank here. And the water comes in from the well or surface water source up and into the first treatment process, which is at the top of the hydro robot, and this is called the aerator degasifier. At that point, any gases that are present in the water, gases like hydrogen sulfide, carbon dioxide, methane, radon, are instantly removed. That particular aerator degasifier, or ejector as we call it, also provides for oxidation of high levels of iron instantly. So the water passes through the ejector and enters the top of the hydro robot. One thing I would mention, characteristics of this plant, is that we need a minimum of 65 psi inlet feed pressure for our ejector to function as it's designed. So as the water enters the top of the hydro robot, its iron is oxidized, and that water flows down to the bottom and into the bottom of the DEFERUM tank at this point here. Once in there, the water flows upward, and it engages with our floating polymer media. Now this is a very effective media for removing oxidized iron, suspended solids, turbidity. The filtration capability of this media is down to 1.5 microns, and you can think of it as a floating sand filter. But it significantly outperforms a variety of multimedia filters and other type of conventional filtration systems that are on the market today. So as the water flows up through the floating polymer media, it is retained by this ring. And in the top part of this plant is our purified water, which we will refer to as filtrate. Now, as the plant is in its service flow, eventually the media gets contaminated with suspended solids and oxidized iron. And when that happens, I want to explain to you a little bit about how the system goes into backwash. Now, as the media loads up with suspended solids, the flow through the media slows. And as a result, we get a backup of water in the hydro robot. At a certain point, this whole system switches into a gravity backwash filter mode. And what happens when that during the backwash filtration cycle is that all the water in the top part of this plant quickly flushes. The backwash cycle on this plant is about a minute. On our larger plants, ranging up to 100 gallons a minute, it may be 3 to 5 minutes. In this plant, this water is roughly about a cubic meter of water. It quickly flushes, and you'll see it coming out of this port right here. This particular backwash water then can be drained to the ground. It can be drained into a tank where the suspended solids separated from the backwash, and the backwash water can then be recycled in through the system. This is what we call a zero backwash system. So the other benefit of this particular backwash is that we designed these systems to not backwash more than once per day. And this results in our backwash flow volume between 1.5% and 3% of daily flow. So this is basically how the system works. In this particular model, we have incorporated a very positive feature, and it enables us to recycle the filtrate and the system. And this is done simply through this valving arrangement. So in order to recycle the water, we incorporate a recycle booster pump, which is plumbed into this particular line right here. And when that option is installed, it gives us the ability to recycle the filtrate, which is our purified water. It also gives us to recycle oxidized water and enable us to add any reagents or like possibly ozone to address a whole variety of other contaminants like high manganese, arsenic removal, and a number of other features. So we built a lot of flexibility into the operation of this particular plant to enable us to do a wide variety of treatment processes. We can combine this technology with membrane technology in brackish water and seawater applications, and we're doing so in some very large treatment infrastructure applications in Africa, and those particular ones, these systems are made out of concrete tanks and are quite larger scope. This other valve bank with the yellow handles is primarily your filtrate discharge. The water, after the contaminants have been removed, then is at atmospheric pressure. This is one of the characteristics of this plant. And it can be drained either from the midpoint of this tank or at the top of this tank. And it simply drains off into this particular port or that one, and then can be connected to a booster pump and pressure tank to repressurize the system. So this is the DEFERUM 24 model. These systems come in small domestic units at 12 cubic meters per day, which is about 1.5 gallons a minute. This DEFERUM 24, which is 5 gallons a minute. Then we have a larger model that's called the DEFERUM 100 to 250, which ranges up between 18 and 36 gallons a minute. And our largest serial manufactured model is our DEFERUM 500, which is approximately 90 gallons a minute. If you have any further questions, please contact myself at 604-219-7898 or visit our website at www.deferum.com. Thank you.